Solving quadratic equations, part 1. There will be a series of videos on solving quadratic equations. In this first part, we will look at the simplest of all cases. Let's recall by thinking about what quadratic expressions are. In a previous video, you saw quadratic expression looks like this: ax square plus bx plus c. Now there are so many letters, but know that a, b and c are just numbers. So a, b, c are real numbers. So the only variable is x. There's only one variable, x. Everything else is a number. And moreover, if they are real numbers, one or more could be 0 except a. If a is 0, then you don't have a quadratic expression. Now this is a quadratic expression. What is a quadratic equation? So equation means it got to have an equal sign. So let me write down ax square plus bx plus c is equal to, I can write something here, but I can always rearrange so that there is just a 0 on the right side. So this is a quadratic equation, ax square plus bx plus c equal to 0. Now this is called the standard form of a quadratic equation. Now we will talk about how to solve a general quadratic equation a little later. Today, in this video, we'll look at the simplest of all cases. I can have b and c both equal to 0, and let me take a equal to 1. So let's start with a simple example. Solve. I'll say example 1. Let's look at this. X square is equal to 4. Now, if I want to solve, so this is a quadratic equation. Here, a is 1, but b and c are 0. Oh, actually, I'm sorry. C would have to be something. I don't have a 0 over there. On the right side, it's x square is equal to 4. Anyway, this is a quadratic equation which has b equal to 0. Now, how do I solve this? It's very easy. Can you think of a number whose square is 4? And you may say it's 2. 2 square is 4. But we also realize that negative 2 square is also 4. So I can say x is equal to 2 or x is equal to negative 2. I can write both of these as plus or minus 2. All right, let's look at one other example. This time, let's say x square is equal to 25. In that case, x is plus or minus. How do I get 25? By squaring a 5. Whether I square positive 5 or negative 5, I get that answer of 25. Now let's look at a number, another equation where it's not a nice number like 4 or 25. So let's say I have x square is equal to 8. Now 8 is not a perfect square. So what do I do there? Just like in the previous two examples, what I'm going to do is I'm going to take x is equal to plus or minus. Now, it would be square root of 8. I did not mention it here, but I could have written square root of 4 instead of 2. But square root of 4 could be simplified to 2. And here, square root of 25 was simplified to 5. Now, in a previous video, we saw how to simplify a radical expression like that. So we break 8 as 4 times 2, and then we can pull the 4 outside the radical. 4 will give me 2, so that's my answer. X is equal to plus or minus 2 square root of 2. Let's look at one other example. Example 4, I'm going to say y square is equal to negative 50. How do I solve for y? I'll take square root on both sides. So when I take square root on the left, I get y. But I have to introduce a plus or minus, and it is square root of negative 50. Now let's recall how we simplified square root of negative 50. So I still have the plus or minus, and within the square root, I'm going to write this as 25 times 2 times negative 1. So I have this answer. The 25 comes out as 5. The 2 has to stay within the square root, and the negative 1 would just give me an I. Alright, so without the negative, it would have been just 5 square root 2, but the negative under the square root will give me an I. Alright, let's try one more. What about t square equals square root of negative 16? Well, actually, I'm sorry. I meant to give you this. T square equal to negative 16. Then t is plus or minus square root of negative 16. And that would be plus or minus. The 16 will give me 4. And the negative under the square root will give me an I. So we looked at 5 examples where I had just a variable square on the left. So x square or x square. And here I used y square and t square. So how do you solve that? You take the square root on both sides. But sometimes I may have a little bit more complicated expression on the left. So say it's x minus 5 quantity square equals 16. So this time I don't just have a variable square like t square or y square or x square, but it's this quantity x minus 5 which is squared. Nevertheless, the process is still the same. I can get rid of the square by taking the square root on both sides. So when I do that, on the left I would have x minus 5, but on the right I would have plus or minus square root 16. So I can simplify this expression. X minus 5 equals plus or minus square root 16 is a 4. And now I can add 5 on both sides. So when I add 5 on both sides, I would have 5 plus or minus 4. So now my answers, I have 2 answers. In one, I will be using plus. So x is equal to 5 plus 4. Or in the other, I will be using minus. X equals 5 minus 4. So these are my 2 answers. X equals 9 or x equals 1. So anytime I solve a quadratic equation, I will get 2 answers. Sometimes those answers are real, like this, or sometimes they are imaginary. And sometimes I may get only 1 answer. So let's look at one example like that. So say example 7. What if I have L minus 5 quantity square is equal to 0? If I were to follow the same process, I would take square root on both sides. I get L minus 5 equals, and anytime I take square root of a number, I got to have plus or minus square root of 0. So L minus 5 equals plus or minus square root of 0 is just 0. So if I add 5 on both sides, I get L equals 5 plus or minus 0, which means it looks like I will have two answers, but one is 5 plus 0, the other is 5 minus 0. So it so happens that L, there's only one answer. L equals 5. Now you can say that there are two answers, but both answers are 5. Sometimes you may want to see it like that. But in any case, either you have a single real number for your answer, or you may have two real numbers, two distinct real numbers, or you have two imaginary numbers. So what we covered is called square root method. So there are several ways to solve quadratic equations. And what we did today is called square root method. And when does it apply? It applies when we have these cases. When on one side you only have a perfect square. It could be just the variable square or some linear function of the variable square. And then you take square root on both sides. You write plus or minus and you simplify. Sometimes you may have to add or subtract a number on both sides to get L by or the variable by itself. And sometimes you get it right away, like here. If you have a minus, then you'll have an I. Your answers are going to be imaginary. So this was quite straightforward. The square root method, you just take square root on both sides and get your answers that way. But it cannot be done for every single quadratic equation. And when you can use square root method is in problems like these, the ones that we already did, and also in all these practice problems. Notice, on one side of this equation, on the left side, if you observe, I have just x square, y square, x square, m square, n square, x square, or some quantity squared. So this is telling me I can take square root on both sides. So I could use square root method to solve this quadratic equation. So that's all I have for this video. Be sure to practice these problems. The answers will be in the video description. And I'll see you in the next video. Thank you.